Hello, everyone. Welcome to today's developer coaching webinar. My name is Tara Van Cleve, and I'm part of the Developer Relations organization here at Oracle. And today we're excited to walk you through the Context Engineering Flywheel end to end and to get into some live coding with Oracle AI Database. If you have any questions, we have enabled the Q&A section of the Zoom, and we will answer throughout the hour as well as leave some time at the end for any remaining open questions. So today's webinar will be presented by Richmond Alake, Director of AI Developer Experience. So without further ado, Richmond, over to you to take it away.
Excellent, guys. My name is Richmond, and I'm over here at the Developer Relation Organization on Tara's team. And I'll get straight to it, right? Today, we're going to be talking about context and memory engineering. And those are like two buzzwords that everyone's hearing in this space. And one thing I want to do today is make those buzzwords real, show you what we mean by context and memory engineering in practice, and get you guys building AI agents. So a couple of things. You can use the Q&A. You can use the Q&A feature to ask me any questions related to AI, obviously, and I'll do my best to answer. And that will allow me to one share my knowledge, and also just listen to you guys and see what you guys want to hear more of from me. So another thing too, every Thursday at the end of every month, the last Thursday of every month, I am going to be here bringing to you the latest and greatest from the world of AI, applied AI, what's happening in this space. We live and breathe this every day for developers and customers, and we want to have an outlet to just the general public to show what we're learning and what we're building and some of the patterns that we're seeing. So this is what an example of this. And several folks from the team are going to be coming to you every week. For me, it's going to be every Thursday, the last Thursday of every month. And that's because Thursday is the new Friday, and people are much happier on a Thursday. And okay, so I'm Richmond Olake, and most people know me for agent memory and memory engineering. I'm going to be talking about a lot about that today, but I'm also going to be talking about context engineering, so we can start putting a lot of that into practice. And one thing I'm focused on is building reliable, capable, and believable AI agents and educating people on how we can do that. And educating people like yourself, such as AI developers, engineers, and AI practitioners. So if you're interested in building AI agents that can remember, um, I am your guy and Oracle is your database. So let's get on with this. So we're going to go through some slides so we can level set some keywords and have a good sense of understanding on what we mean by agent memory, context engineering, and memory engineering. Then we're going to go into some code. You guys are going to get the link to the code. It's always on our Oracle AI Developer Hub. For those of you who are no strangers to what we do over here, you have a link to that repository and you'll be able to access the code there as well. One thing I also want to mention is, yeah, Tara, actually, um, the zero to hero notebook, the one I'm going to be showing today is going to be a different notebook. I made a last minute change, and I made a last minute change because there are some new things that are happening in this space, and I wanted to update my notebook and just show things happening directly in this notebook. So we're going to see context engineering techniques such as context offloading, summarization, and so I'll give you guys a new link for the notebook, and but still the one that Tara shared is very useful. Zero to hero, rank to agent, zero to hero is very good. All right. On that note, ask any questions. I'm going to be monitoring the Q&A box just so I can answer questions as I move along. There are no stupid questions, so give me all the questions you can think of. Let's talk about the maturity levels we've seen in AI over the years. So we started off with LLM chatbots. So you had GPTs behind the chat interface, and then you asked it some intelligent questions like spell strawberry, then it would give you a natural language response. That was great. It got a lot of people excited, but we needed to move on to actually getting real use cases out of this LLM enabled chatbots or chat interfaces. And we did that by aligning them with domain specific data. So we aligned them with domain specific data, and this allowed the LLMs to ground the response and essentially give us better responses to our queries and reduce hallucinations from these LLMs as well. So we moved from LLM chatbots into the RAG application era, And from the RAG application era, we had two branches, right? We moved into the autonomous era, the autonomous branch and the automation branch. So let's talk about the automation branch. And that's more looking at workflows with predetermined step. And you have this intelligent entities like LLMs that can actually just operate within the process and give the next output to the next predetermined step. This is what most people want. Most people want automation, but the holy grail is autonomy, where you give the LLM a bunch of tools and you give it an objective and it does the objective using the tools that you've set it. So the holy grail is autonomy, and we are getting there. Um, Seems we're getting there and we get closer every single day. OpenClaw is an example of an autonomous AGI, or even I'll call it AGI. Cloud Code or Cowork is example can work autonomously with a bunch of tools. But yeah, we're gonna show you how to build these systems and make them memory aware and augmented. So let me just quickly go over some of these things again and with some visuals. It helps to visualize some of these application form factors. So we had LLM chatbots, right? Interacted with them. You just got generic responses, but we needed to go one step further. So you have a database, a data source where you can pass in some grounded data with the queries from the user, and you get better responses from your LLM. It became more useful. But then we moved into this workflow automation branch where we had predetermined step with the outcome, or when we wanted a human to come within a loop. And we had LLMs within these steps that are able to ideally create some natural language or handle edge cases in a sense. And this allowed us to start moving into multi-step workflows, orchestrations, and just having more autonomous, more automated systems. Now we moved into the era of autonomous systems as well. That was the other branch where you have an AI agent, which is a computational entity that can perceive its environment it could perceive its environment such as looking at images or audio. And then you also can take actions, right? You can take action through tool use, or you call it function calling, connected to MCP, or getting more data. Then you can actually, the agent actually needed to reason. And the reasoning capabilities was enabled by an LLM. And the most important bit, it needs to have memory. It needs to remember, it needs to adapt, it needs to be reliable. And that's where we're at with what we see as an AI agent. Now, I'm going to go over RAG very quickly. Like I said, I'm going to make no assumptions. So I'm going to go over RAG, and I'll take you from RAG to agent memory. Then we could go into context and memory engineering. And the reason why I'm going over this is because in the code, we're going to be looking at all of this in practice. Again, ask me any questions. If you need some clarification as to what I'm sharing on the screen, feel free to ask me any question. RAG stands for retrieval augmented generation, where you have a data source, pass your data source through a data processing pipeline, which usually involves chunking your data object into little chunks that you can pass into an embedding model to get a numerical representation of your data object that you've passed in. Now, this embedding model essentially gives you a numerical representation, which we refer to as a vector or an embedding or vector embedding. But you also have other data with your chunk, such as any JSON data describing some of the metadata in for the content. You can have text-based data. You can even have some data that represents relationship essentially within your data object within your chunk. The the key takeaway here is whenever you're dealing with things in the agent space or even in production, you're going to meet and encounter different types of data, right? There is a heterogeneous nature to the type of data you're going to encounter in production, and you need a database that can handle all of that. So we talk extensively of the converged database that is Oracle AI database, the benefit of this. In the future webinar, we'll probably go more deeper into this. What does it look like when you use a multiple database versus when you use one database? So, but generally, what we have here is one database that can handle all the data agents encounter in production. And when I mean by handle, it means providing all the retrieval strategies, the storage optimization, and all the bells and whistles. But going back into RAG, so we've ingested our data. Next, we will have a user that will possibly ask a question. We take the user query, embed the user query with the same embedded model we use in that data ingestion process. And then we can then use that to conduct semantic retrieval powered by vector search, get a certain number of documents, maybe about 10 to 100 documents that are related to the user query, pass that through a re-ranking model for those of you who love to live on the wild side of the machine learning of machine learning. Then you then use those documents, the re-ranked one, pass that into a large language model. Then you get a natural language sound and response back to the user. That is RAG, Retrieval Augmented Generation. Okay, that was a lot. If you have any questions, feel free to ask. But I need to go over this because most people think RAG and agent memory are two separate things. They're not. RAG has the retrieval part of RAG is very important because that's what we use in most of the agent memory and context retrieval techniques as well. So this is always good to have in the back of your mind that you can take your existing knowledge into this new shift we're seeing in building AI agents. Okay, so we remember this guy. This is our agent, right? The one that could perceive, that could do things such as reason and take actions. Okay, someone says they're a little fuzzy on the parts on the augmented with re-rank documents plus something. Okay, I could go back and I do want to bring as many people along as I can. So thanks for asking that question. So the augmented aspect of it is this, right? When you're augmenting information, you're usually putting more information with your initial information to enrich it in some sense. In this sense, the augmentation is we have the user query is been augmented by some retrieved documents, right? Before we just used to interact with the LLM, but to make it useful, we need to actually augment it. And this allows it to perform better. And in terms of perform better means respond to us properly in the way that we expect. Then the generation aspect of it comes from the LLM because it's generating tokens which will pass through a tokenizer that would give you the actual text of the text representation of the token. That's a generation of it. So augmentation is nothing new. We've done this in machine learning. Back People still do this today, but back in computer vision and deep learning, we used to have images. And to make our machine learning computer vision models more robust, we used to augment our data sets by rotating the images to mimic some of the diversity in production scenarios. So, for example, imagine you have a face detection system. You want to be able to, for your face detection system to work even when the user or the user of that system is rotating their face. So that's what augmentation is. It's nothing new. It's existed in machine learning in different ways. Going back, we have our agent over here, and we know this guy. We've seen him before in previous slides. Then we have a bunch of memory. In a previous webinar, I covered agent memory. So you can always go to our Oracle, you can always go to our developer resource page. Tara, if you can link it to the folks here, you can watch a previous webinar where I spoke about agent memory, and then more of this would make more sense. But agent memory essentially is just trying to create a system that mimics the way humans remember, but in computational form by creating abstractions that can encapsulate different types of information within an agentic system that we refer to as memory. So whenever data enters the agentic boundary, to me, it becomes memory. Everything is to be remembered or forgotten. Now we still have, if you want to take things into the agent memory paradigm, you still have that ingestion pipeline we saw in RAG, and you can take that within agent memory, and you still have everything living in your database, and this is what we have as memory for our AI agents. Okay, I'm trying to make my way into context engineering, and we're going to go into some code very soon. The whole point of all of this is to make sure that we're all going along, we're all learning. And like I said, we are going to be showing up every week, myself every Thursday, last Thursday of every month. So it's going to be very progressive what we keep learning each month. And for those of you who can't wait 28 or 29 days of the month, you can always follow me on LinkedIn or just, yeah, follow me on LinkedIn or follow Oracle AI Developer Blog Hub to see the technical assets we're putting out. And yes, we will be sharing the slides after this. It will come to you in an email. Okay, prompt engineering, we should all know what prompt engineering is. It's just putting a bunch of text into the context window of the LLM to make it act in a certain way or get a desired behavior. But there are different prompt engineering techniques, and we'll go over them very quickly. But as the LLM's ability to reason improved, it meant that we could reduce the amount of prompting we had to do for the LLM to behave. So we had the I guess the liberty now, we have the liberty now to actually think carefully about the information we put into the context window. So this leads us into context engineering, where we could optimize the information in the context window and make sure that we are getting the most bang for our buck, or even to put it into technical terms, every token in the actual context window has a high signal, right? Now, today we're going to be looking at memory engineering. We're going to be looking at context engineering techniques and memory engineering techniques and how they work to build AI agents that remember. But with context engineering, there are different techniques, right? There was chain of thought, there was react, reason and act, then reason, observe, then act. Then there was few short examples, and all of this leveraged that in context learning capabilities of large language models. And this is what we saw. This is what it will look like. A user enters a query, then you would have this query augmented with different reasoning techniques. One of our one of our team members actually created a very good Python package that gives you all of this reasoning techniques out of the box. He augments he abstracts all of the complexity of implementing this. And he's going to be doing a webinar next week, actually. So next week, Nacho is going to be doing a webinar talking about Oracle AI database, LangChain, and I'm hoping it gives you guys a good gift by sharing that package. It's very good. It saves you a lot of all the handiwork you have to do with implementing reasoning or prompt engineering technique. But moving on, we came into this world of context engineering. Remember, guys, we can now select, we can be picky about what we want to put into the context window because we no longer have to beg the LLM to act in a certain way with so many linguistic patterns. Now we have the luxury of choosing. Now, with great power comes great responsibility. So now that we can choose, we have to start to think about what are these techniques that can optimize this context window. So we're going to look at context retrieval, and there's also context reduction. The context window is always going to expand as we keep on interacting with it. So we have to find ways to reduce it, but we leverage some memory engineering techniques to actually make sure there is continuity in the interaction we're having with our AI agent. There is context offloading, which you're going to see as well. And there is obviously bringing a sandbox into your system, into your infrastructure to be able to execute code in an isolated environment. This is usually code generated by the LLM or maybe some external code accessed by an MCP. You execute that within a sandbox environment, and then you get the output of that execution back into the LLM. I think I think next month, when I come here again at the end of March, I will show a sandbox, what a sandbox environment or implementation can look like within your agent harness. So I'm going to talk next month. I'll talk about agent loop, agent harness, and sandbox. Okay. So we'll get that webinar on the card, and you guys can attend the next month's webinar where I talk about those three things. But there's a bunch of context engineering techniques, and this is what we're seeing people use it for. So you have a retrieval engine, you still have that database, your Oracle AI database, you retrieve all your context from it, but the context window becomes an area where you start to organize, you start to optimize as well in terms of capacity. And that when I say capacity, I mean tokens filling up this space. And you have to be aware of the token limits as the token capacity of the context window as well. And now I'm going to move on to what we look at, which is the context engineering flywheel. There's so many different techniques in context engineering. But there's some key basics that really matter. One is context window utility. For you to optimize your context window, you have to know how it's being used and the capacity of it, right? You have to know when you're reaching that threshold. So all the context window in LLM are bounded. So for example, some of them will have maybe 258,000 tokens that you can fit within a context window, and some go upwards to 1 million. And for those of you who are aware, you start stuffing 1 million tokens into your context window in one iteration, you're going to run into problems such as context rot, also lost in the middle problem. So all of these, there is always, even though you have large context windows, you still have to think about ways you want to optimize it. You don't want to use all the context window at any single point, to be fair. So context window utility is very important. Context organization is important for both context engineering and memory engineering. And let me talk more about this a little bit, then we can start going into some code. So context organization is an interesting one. One thing that we've done or we understand now is that LLM have this latent understanding for structure. And that's because they were trained on internet data. And internet data is structured in a sense, right? There's a bunch of HTML, XML, Markdown, all of these file formats that have structure within them. So if you think, for those of you who are web developers or used to be web developers like myself, if you think of an HTML page, you have a head tag, then you have a body tag, then even before the head tag, you have the HTML tag, then the head tag, the body tag, then you have sections within the body tag. And all of this, the LLM has been trained to understand the structure of data within these different file formats. That means we can leverage that in the way we structure our context, right? To be able to tell our LLM to start to reason about the structure of the information we're giving it. And we actually reduce that reasoning of structuring fact, right? We actually say, look, we're going to organize this information for you. I'm speaking to the LLM, by the way. We're going to organize this information for you. We just want you to focus on other reasoning that you need to do about the information. So we don't want you to be too worried about how and when to use information or the content of the tokens you're being given. That's what we're doing. We're front loading some aspect of the cognition that the LLM has to do. That's how I see it anyway. Okay, so the rest of it is context isolation, context retrieval, reduction, and offloading. We're going to see majority of these today. So I want to get to the code. So we'll spend 2 minutes on this, then we'll go into the code. And if we have some time, we'll come back into the slides. Um, this is a typical context window, right? Let's imagine it has 120,000 tokens, and that's nothing in terms of today's capabilities of this LLM. You typically would have like a skill MD or agents MD. And one thing I'm reading now, for those of you who actively follow the AI space, apparently skill MDs and agent MDs are dead. In AI, we seem to kill things every month or every week. So apparently they're dead. Apparently we need to start doing something else. And you literally fill up your context window with a bunch of information and you can utilize a bunch of tokens. But when you start looking at some of the context engineering technique we're going to look at, such as context offloading, one thing you can do is, for example, for tool outputs, they're usually fed into the next iteration of your agent loop. And one thing you want to do is remove them, right? The tool logs are not that useful for any subsequent iteration. You can remove them, you can put them into a database, right? And then retrieve them if you need to. Again, conversation can be summarized, right? You go into context summarization. Conversation can be summarized. That will be a context engineering technique. Putting into a database and then optimizing the retrieval of it is a memory engineering technique, right? So then context retrieval, it sits on the line of memory engineering and context engineering. And all of this can reduce your token, right? Can reduce your token with your context window capacity, right? When you start using all these techniques. And we've spoken about agent memory. I'm just going to go over this very quickly. there's a link to the webinar that you can watch where we went over this very in more detail. And the reason why you're seeing it here today is because we're going to speed run through agent memory and go into some of the context engineering technique. Remember, what I'm doing every month for you is just get a follow on from all the knowledge that we're getting. I'm not going to start from scratch in most times. We're just going to build on all the knowledge. And hopefully by December, we'll all be AI experts. Spoiler, there are no AI experts. A key term you want to take away from this is I want you guys to take away from this session is the key term is stateless agent. A stateless agent is one that doesn't remember previous interaction. So in this example, I guess it would be cool if I did it with the animation. So in this example, you have turns with an AI agent, and you ask the AI agent for a holiday recommendation, and the agent will tell you Singapore has become popular. Then in turn three, you will ask, can I get some information? And the agent says, about what? What do you want from me? And that's because the agent is stateless. It can't remember. But then you could have the same scenario where you have the same question asked, Singapore has become popular, is what the agent is going to respond to. But those interactions are stored in an LLM, not in an LLM, sorry. Those interactions are stored in a database, right? We can store that as conversational memory. And here you can see a model here that is an embedded model because you can store an embedding with it as well, even to do semantic retrieval against conversational memory, which might not be what you want to do. There are other memories that are more favorable or more aligned to semantic retrieval. Long story short, your agent now has memory, and now you get a proper response from your agent because it can remember what you're talking about. You're talking about Singapore, and now it can carry on the conversation. This is a memory augmented agent, right? The agent is augmented with memory. One thing I also want to point out is there's a difference between a memory aware agent and a memory augmented agent. This is an example of a memory augmented agent, but a memory aware agent is one that is aware of its memory stores capabilities within its tools description, within its system prompt, and within the whole context window. The context window is partitioned. That agent is memory aware. So there's a difference between memory augmented or memory aware. And that's an official definition of agent memory. And now we're at the halfway mark of this webinar. Let's go into the code. So I always try to keep the code to about 60% of this webinar, but 50-50 is not bad. VS Code is my weapon of choice. So on the screen right now, we'll start at the end and then we'll make our way to the beginning. And the end of this notebook, which you will get in the Oracle AI Developer Hub, and I will actually update it right after this webinar. And I'm going to send a link to this notebook on the chat. And you will see, because we actually update all of the content in the Oracle AI Developer Hub every single day, because we keep learning new things. You're going to see an old version of this after this webinar. I'm going to put out the new version. So I'm going to share this, and I'm sure Tara's already shared this. I'm going to share this right here. No, I'm going to share again right here with everyone. And this is a notebook where you're going to see the updated content that we shared in this webinar. Okay. Keep the questions coming. I will save 5 minutes at the end for questions. All right. So on the screen, you can see it. You can see a chart. It means nothing to you, but that's about to change. In this notebook, we're going to have two agents, one with context engineering and memory engineering techniques, and another with essentially is just a naive agent. So no engineering techniques, just we're passing in all the conversations into the context window at every iteration of the loop, of the agent loop. So as you can see, this line shown is the utilization of the tokens of each of this agent. And you will notice that the context and memory engineering agent starts off with a very high token usage because we're putting information into this agent and it has memory, so it knows some pre-configured or pre-ingested information. And now we start off with some token usage, but you can see that the jump between token usage is not high. And it can even start to reduce when we start to bring in things like summarization and context offloading. So you can see that here, this token reduces and then we go on a stable increase. But as you can see with a naive agent, we just keep going up, and we have the jumps are more prominent between each iteration. Why am I showing you this? Because this matters. If you build an agent without any context engineering or memory engineering techniques, your agent is just going to keep putting more content or more context in its context window, right? I don't like to say the word context twice in a sentence. So your agent will put content within its context window, right? More and more content at each iteration. Eventually, the performance will start to degrade. You're going to start to see things like context rot, context bloat, lost in the middle, all those keywords that we see that are not nice words we're going to be hearing. Now, where this is where memory engineering and context engineering can save you all of the pain you have when you get to production. Now, this is what this notebook ends at, right? We show you all of this. We show you how to implement both agents, and we show you the best of both worlds. With Naive, there is no best of both worlds. Maybe less code you have to write. So this notebook is split into parts. We're talking about memory and context engineering. We're going to be using Oracle AI Database as our agent memory core. I'm going to explain what agent memory core means later. I think that's an important concept that I want people to come away with. We're also going to be using LangChain and Tavily. These two libraries are very popular. LangChain is an abstraction framework for LLM and RAG pipelines, while Tavily is how you connect your LLM to the internet. And like I said, we covered agent memory in a previous webinar, and some of you might know what these are. These are different memory types that we have within our database, and these are just tables in our database with different retrieval strategies based on the data that they hold. So some of these tables have vector data in them, so we actually retrieve using semantic search, and some of them don't have any vector data, and we just retrieve using traditional retrieval strategies or using time-based retrieval strategies, right? The key thing is with Oracle AI Database, you can use graph, vector, lexical, which is text or keyword, any of the different search techniques you can think of in one database. Now, the second part of this talks about vector search and how you can use it with the LangChain Oracle integration, and it makes things a lot easier. Then in part three, you start to learn a lot about memory engineering and agent memory, which I covered in detail last month, at the end of last month. But in this part, what we're seeing is an implementation of a memory manager, and which is a memory manager. Let me actually just get that right here. A memory manager is just an abstraction, just a layer of abstraction between our agent and the database, right? It helps simplifies a bunch of methods and complex operations to read, write, update from the database, because it just makes things simple to think about from both a human and an agent perspective. So the memory manager encapsulates a lot of code to interact with the database. And there are different types of memory manager, right? You might hear them in the space, some of them, M0, that's a memory manager. LangChain has a tool called LangMem, which is a memory management framework. They're just abstracting the complexity of memory operations that you will build. But for me, I like to teach people from the basics. So we're going to be building our own naive memory manager. So this is the class here. It's called Memory Manager conveniently, and it goes through different types of mostly read and write operations for all of the different type of memory that we have in our memory augmented / aware agent. And that's what that is talking about. Another key takeaway another key point I want you guys to come away with is whenever we talk about memory operation, right? You have to, there are two classifications for it. You can have a programmatic operation or deterministic operation, or you can have one that is agent triggered. Now, what do I mean? You can give your agent tools for it to manage its own memory, or you can just write the code for handling memory yourself. There are pros and cons to each of these to each of these methods. Ideally, it's mostly design and in terms of what you want to actually, how you want your agent to operate. For example, most of the read operations are programmatic. I do allow the agent to read from memory by using this expand summary, and that can be agent triggered because our agent is going to be able to summarize its own conversation by itself, but it's also going to be able to be able to expand it when it needs to. You can think of it as like double clicking in a link. We're going to see what that means. But the key thing is there is some design choices you have to make as a developer when you're building memory aware systems. Which memory operations do I want to make deterministic, and which one do I want the agent to have access to? And these are fun choices you can play with. And the keywords such as harness, I'm going to touch on harness next month. Like I said, if I spoke about all the keywords in AI today, we're going to be here for forever. So it's good to split this into months. So we're going to talk about harness next month. So next month we're talking about agent loop, agent harness, and we're going to talk about sandbox. So remember those three, and you can keep me accountable. So you come in next month, you don't hear me talking about those three, you'd be like, Richmond, you said we were going to talk about those three. So we have the memory manager is implemented. We have all of the read and write methods. Of course, you can update memory and you can delete as well. But a principle of memory engineering, if you listen to me, is you don't delete memory, you forget. We could talk about forgetting mechanisms and how you can implement forgetting in your memory system in the future. Okay, so let's go into the execution of this agent. I actually want to go into the agent execution. Um, well, I'll talk about the context engineering. Some of the context engineering that we're doing are very simple but very powerful. For if you remember the flywheel, right? We had context window utilization as the first part of the flywheel. So this is making sure we know how our context window is being used in terms of the content within it. So we have a function called calculate context usage, and this allows us to see the token capacity and the full token capacity and what's been used. And then we can allow our agent to either summarize the conversation when it reaches a specific threshold, or we can do that programmatically ourselves. That is what we mean by context window utility, and just having given the agent or yourself an awareness of how the context window is being used in terms of token capacity. Another context engineering technique, if you look at the flywheel again, was context reduction. We're going to look at context offloading as well, but context reduction can come in two forms, which could be compaction or summarization. With summarization, you're using an LLM and you're passing in an uncompressed information, and you give it some instructions on how to compress the information, and it gives you a compressed version of that uncompressed information that is should be smaller. And now you can remove the uncompressed information from your context window and use the smaller compressed information. But again, we don't delete when in agent memory, we don't delete, we just forget, or at least we try not to delete. That's the key takeaway. So what I mean by that is whatever you're throwing away, you're not going to really throw it away. When you come into memory engineering, what you're going to do is you put that in a database, right? You put that in a database, put that in summary memory, which is a type of episodic memory. And what you can do is now put a placeholder in a context window and put an ID that points to where that is where the full summary on summarized content is located. What that means is you can go into just-in-time retrieval, which is another context retrieval technique for context engineering, where you can just retrieve information you need just in time when you need them, no pre-computation. So, and this will be a tool for your agent, right? You give a tool to the agent to be able to do this. I've said a lot. Keep the questions coming. I'm going to answer some questions now. Someone asked, how can you make sure there is no loss of information when you do compression? Well, there is going to be loss of information. The way you make sure there is no loss of information is by doing what I just said, which is you offload the uncompressed content into a database, and you can retrieve it when the agent needs it, or the agent can retrieve it when it needs it. We're going to see that. Someone saying, should we use quantization plus augmented memory? will that will help us reduce token per session per topic? Well, okay. You use very quickly, and maybe we can touch on this in the future in terms of quantization. You use quantization when you want to reduce latency, right? Or you want to reduce latency. So with quantization, you can quantize in different the quantization can be applied in different areas of your agentic system, into your LLM or to the outputs of your embedded model, or even within the database itself. There are different parts you can implement quantization techniques. Generally, you're going to use it to reduce latency because you're now storing information in a reduced representational, in a reduced, uh, I guess, using reduced precision data type. So embedded models, the vectors you actually generate, they're usually in float 32. That means each value is stored with 32 bits, but you can reduce this 32 bits to 16 or 8 bits, right? Because there are some embedded models that are quantization aware, right? Again, this is like a whole different topic, and we could do a whole webinar on this. Long story short, you use quantization for reduction of latency, but there is a cost to that. You might lose some accuracy as well. Oh, that's another webinar for a future month, actually. So let's go back into this, into the context engineering techniques we cover. I actually want to just go straight into the execution of our agent. We've got about 10 minutes left. I think we've made good headway in terms of what we're talking about here. So I have an agent and a system prompt for my agent. And one of the key things about the difference between memory augmented and memory aware is memory aware. The LLM is aware of the memory it has or the memory it should have. So I specify this in the system prompts, and system prompts has a higher importance in the space of LLMs, right? Or the instructions you give LLMs. The system prompt has the system instruction has a higher importance than maybe the developer instructions or the user message, right? Those are some of the three levels of instructions you can give to an LLM. So again, this is what we mean by memory aware. The LLM is aware of some of the memory types it has. And also, we're going to see that even in the context window, in the retrieval of different memory, we're able to understand that we're able to tell the LLM how to use it as well, in more detail. So let me quickly go into the meat of this, right? The meat of this lies in this function called call agent. And I'll touch on the keyword agent harness in the future, but call agent essentially will call our agent passing in the right context. And the right context can be built in different ways. Because our agent is both memory augmented and memory aware, the way we're going to build context is by basically using our memory manager to read from conversational memory, read from knowledge base, and read from workflow, entity, and summary context. And we're passing the query as what we use for the retrieval query, the query for our retrieval to actually get some information from our database that is ideally related to the domain or the context that we're operating within. And now we start to build the context. And when we build our context, we can do another thing, which is where we become aware of this context usage, and we can also read tools using the memory manager. Again, I spoke about this in the last webinar, but you can use your database as a toolbox, which really makes it easy for you to not bloat your context window with a lot of tool calls. So memory operations are happening here. There's memory operations happening within the loop as well, such as writing to conversational memory, writing to entity. So within the loop, there are memory operations that happen, and the loop, when I refer to the loop, I'm referring to agent loop. There are memory operations that happen. We also do something which is we take all the tool calls, all the tool outputs, we actually put them into memory as well, because we don't want the tool logs to stay within a context window because they're not useful, they're useless. So we can offload that into memory. I think the GitHub is not in sync with the presentation. So the GitHub will be updated after this webinar. So like I said, we're updating our knowledge every single hour. So we just updated this notebook because we wanted to teach people more about offloading and other techniques, right? So if you go through this notebook, there are ways we offload memory. For example, the memory manager can write information into the tool logs, and that means we don't have to pass in all the, when our agent calls tools, we don't have to pass in all the information in every single iteration of the context window. That's just going to be that's going to be a lot of information, right? So we're extracting the tool logs and just passing it into the context and passing it into the database, and we can retrieve it when we need it. And this is context offloading in a sense. Okay, so and this will be the notebook I've given you the link to will be updated within the next hour because we are learning in real time. There is also workflow memory, entity memory we can write, and these is now we're outside of the loop. The key thing is memory operations happen inside and outside of the agent loop. So this is all good. So let's go. So I then ask, let's actually do this live. Live demos are always risky. So well, let's do this. Let's put a thread ID and let's do this live. And I can show you what we're seeing here. Get me the latest papers on agent memory in 2026. Okay, so we're going to go through the output here. Very quickly, we can start to see we're building our context window. We have the question that we passed in, and the first thing we see is we have conversational memory. And you can see we're using this to mark down hashes, right? Because again, like we said at the beginning, LLMs understand different structures of information in different formats that they're familiar with, because those formats are in the training data. Some of them, Markdown is a very popular format that LLMs are aware of. So they can understand structures such as this. So it's conversation aware, it's memory aware. Our LLM is memory aware. So therefore our agent is memory aware because we're telling it the purpose of this memory type, when to use it, and other information. We can even take things further and even tell the agent to take certain memory units within a memory type with high importance than others. We can go into that realm if we want to. But you have knowledge-based memory, which is semantic memory. Again, the context window is structured in allocation to different memory types. This is just memory aware, memory augmented. And you can see it has some workflow memory. And very quickly, there's a bit of summary memory because I did this before, actually. I've actually run this before. And it actually didn't use any tool calls because I've ran this before. And that's just by chance, actually, because I've used this thread ID before. Let me do this. Let's start with this. That number, I've used that number before, so it didn't do any tool calls. So he pulled the answer from his memory. Again, that shows the point of using memory, but I used a thread ID that the database or the agent has not seen before. Now we're going to see it use the tool call. So before the thread ID I used, even though I put in so many zeros, you can tell I've done this a lot of time. It used the previous memory because that thread ID actually existed and there are memory units associated with that thread ID. But as you can see, with a new fresh thread ID that could represent a new session, we are using the tool search Tavily. Our agent has this tool and it's passing in the query AI agent memory 2026, and it's doing this twice. I don't know why it's doing it twice. I don't know why, but it's gotten the results and it's given us the answer. The brains behind the bots, cool title, and it's given us these three answers, right? I'm going to ask it to just go into the first one. I'll ask it to double click into the first one very quickly. So I'm asking it to get me more information, the first one. And you can see it's still going to have conversational memory of our first message and its response to it. Then it will have some knowledge-based memory from all the data we've ingested previously. And it has workflow memory as well. The workflow memory, it would capture the steps we took before because before we used the tool, workflow memory would capture that as well. Then we can see it's expanding a summary. It shouldn't be doing that, but hey, this is why agent triggered tools are sometimes not what's it called? You can't predict what they're gonna do. So we've told it to expand. It expanded a summary, even though I just told it to double click into the paper, and it's expanding a summary that exists, maybe because the information exists in memory, but it's not gonna get the right information. But it's giving us some information, which is fair enough. But the key thing there is you have an agent that is aware of the information that it has or it has the interaction that's had. So very quickly, the last one I'm going to do, I'm going to ask it to summarize your memory. Well, I'll just say summarize this conversation. Oh, by the way, I'm using GPT-4 Omni, GPT-4o. Yeah, so it's a bit not as good as GPT-5 at maybe reasoning. So use GPT-5 if you're running this. Summarize this conversation using your tools. Okay, we're gonna see how we can use its tools, and you can see it's using its tool to summarize this conversation. Again, the agent can decide to do this by itself if it has an awareness of the context window and it's like, okay, I'm reaching a certain threshold, I'm gonna summarize it myself, or you can just trigger it programmatically yourself. I'm just giving you an example where the agent has access to that tool and it can do it itself. So it's marked 5 messages are summarized, and it's giving us that ID, and it's actually has this ID in there. One thing I'm going to do is I'm then going to say unpack the summary. Because I have the ID, I'm just going to tell it to unpack, and you can think of this as like a double click. And I'm going to show you that the context window, the conversation summary, the conversation memory is now just one entry, right? Because again, we summarized, and not only did we summarize, we just removed the context, the content to the database, but our agent can then unpack if it needs to, because it can expand a summary and then it could use the ID we gave it. Oh, that was the previous step, sorry. It can expand the summary, use the ID we gave it, and get some information. Then I could ask it, even though it's not in the conversational memory, right here, I can ask it, what was my first question? I just ask it what was my first question to you, but I'm just going to go over this slide very quickly. Not the slide, sorry, this diagram. The key thing, again, I started with this, and this is the key takeaway. We are going to be increasing the context window of the LLM if we don't start to go into the world of context engineering and memory engineering. And the disadvantages of this is the performance of your LLM starts to degrade. You have to start going into these techniques and context and memory engineering to start optimizing your systems to make them more reliable. This is where the fun happens, where you get creative and where you're able to start to build LLMs that work well in production. So we can go back up here and see if there are any final outputs. So I asked it to unpack the summary and tell us what our first question was. And let's see, it's saying our first question was not explicitly mentioned. Use GPT-5, guys. This is why I use GPT-5. Now you can specifically tell it to unpack the specific memory we want it to, then it will get you your first question. But I'll update this to use GPT-5 when I push it. But the key thing is context engineering, some memory engineering, they're the way to go to build more systems. To leave you guys, and if Tara permits me, 1 minute, Tara, give me the thumbs up if I've got 1 minute.
Yes.
Thank you. Okay. I'm going to leave you guys with this. There's a lot of the agent memory core, right? You're going to hear about the agent memory core. There's a lot of places, there's a lot of system components within your agentic system that handle memory. Your embedding model and your LLM have latent memory in them because they have training data. And that is a sense of a type of parametric memory, right? But you also have memory in your database because that sees a lot of memory stored that you can retrieve. But when I talk about the memory core, this is the key aspect of your system that is going to see the most traffic of data. Is going to see the most memory go in and out. That is your agent memory core. And that is Oracle AI database. It gives you all of the bells and whistles to make memory work. So I'm going to leave it there. I think we went a bit over time. I apologize. Next month, Tara, I'm going to be on time. There's just so much fun and information to give that.
No worries. So, as Richmond mentioned a few times, this is an ongoing series. We'll be with you on March 26th is our next one. So, we are the last Thursday of every month, and this is the second one in the series. So, we dropped that replay from the first one. But if you want to find it, that's just at our Oracle YouTube. So, youtube.com/Oracle Devs, and then it's within our developer coaching playlist. If you go to the oracle.com/developer events page, that's where all the upcoming events are. And on that page, you can also find the link to our playlist directly there too. And we'd also love to hear your feedback on how we're doing, if you like the session, what you'd like to see next time. So as you exit the Zoom, there is going to be a quick survey that pops up. So we'd love to hear from you. And then I also wanted to let you know that we are coming to a couple cities near you. The first one is London on March 25th, and then New York City on April 10th. So if you'd like to meet us in person, Richmond is going to be leading some of the workshops. So we're going to go from AI data fundamentals and vector search concepts to building a production style RAG pipeline, evolving it into an agentic application with LangChain and Python, and then implementing persistent agent memory for real world production ready workflow. So right in line with the demos today. And we will include that as a resource link as well when we follow up with the replay. And so with that, I want to say thank you so much for spending your time here with us today. And we hope to see you next month. Thanks, everybody.